Hello everyone, welcome to online lecture on ARM controllers. Myself Naveen GC, Electronics and Communication Department from Government Polytechnic, Bandwala. It is a lecture about a first chapter ARM embedded system and ARM processor fundamentals. It is the seventh session of this chapter. In this session, we are going to talk on a different ARM processor modes. We are going to talk on different ARM processor modes. Before starting this class, we will see what we have studied in the previous lecture. As you know, in the previous lecture, we have studied different resistors available in the ARM processor. There are 37 resistors. Out of those 37 resistors, 20 resistors are banked resistors. Another 17 resistors are visible for users. And also we have studied different active resistors in the user mode. Different active resistors in the user mode. Then we have studied CPSR, important status register, that is current program status register. In that we have studied bit structure of CPSR and different field present in the CPSR. Then what are the different fields present in the CPSR? Because it's very important. One is extension, status, then control field and flag field. Okay, so then we talked about another status register, that is SPSR, saved program status register. Okay, while talking about CPSR and register, I told some of the processor modes present in the ARM controller. What are those? Abort mode, FIQ mode, IRQ mode, SVC mode, undefined mode, user mode, and another one is system mode. In this class, we are going to talk on these processor modes. In this class, I plan to cover these topics. Number one is introduction of processor modes and also details of processor states and also exceptions and their priorities. Some of the comparison between ARM state and thumb state. Finally, some multiple choice questions to check your understanding level. These topics we'll discuss in today's class. Learning outcomes. Learning outcomes of this session are, at the end of this session, you will be able to explain the different processor modes, and different ARM processor states. So next, you will be able to list the sequence of action taken by the processor when exception occurs. Exception is nothing but it is a form of interrupts. We'll discuss later. After that, you will be able to list the different exceptions and their priority in the ARM core processor. Finally, you people have able to interpret the processor operates in which mode and which state by analyzing the CPSR. These are the learning outcomes of this session. Processor modes and states. As you know, in ARM controller we have 7 different processor modes. ARM processor can operate in 7 different processor modes, namely user mode, abort mode, FIQ mode. FIQ means fast interrupt request mode. IRQ, normal interrupt request mode. SVC means supervisor mode. Undef mode means undefined mode. There is one more processor mode, that is system mode. So these are the 7 important processor modes in the ARM processor. Processor also can operate in the 3 different states. ARM processor operates in 3 different states. What are those? Number 1 ARM state, number 2 thumb state, number 3 Zazzle state. So these are 7 processor modes, and 3 processor states. Okay, what are modes? What exactly mode means? According to direct dictionary, mode is nothing but it is a way or manner in which something occurs or something experienced, something is done or something expressed. So this is called mode. Processor mode is nothing but processor mode refers to various ways. It refers to various ways the processor create an operating system for itself. It will create operating environment for itself. That refers to processor mode. The processor mode controls what? How the processor sees and manages the system memory and the task. It controls processor, how processor sees and processor manages the system memory and the task. It also determines which register are active. It also determines which registers are active, which register having access rights to the CPSR register itself. So this is about processor modes. ARM processor modes. As you know, we have 7 different processor modes available in the ARM. Based on the read-write axis of a CPSR, we can categorize these 7 modes into 2 different modes. One is privileged mode, another one is non-privileged mode. Based on the read-write axis of a CPSR. Privileged mode is nothing but these modes have full read and write access to the control field of a CPSR. Do you remember control field of a CPSR? There are 8-bit, it's a 8-bit field. In that 0 to 4 is a mode bits, then 3 IFT bits are present. For those fields in privileged mode, they are having full read-write access. They can read and also they can write. So this is in the privileged mode. In privileged mode, control bits may be changed. In privileged mode, control bits may be changed. User, that means that programmer can change processor mode, can enable, can disable interrupts or privileged operation. These are privileged operation in the privileged mode. That means programmer can change these operations. But in the case of non-privileged mode, it has only read access to the control field of the CPSR. It doesn't have a write axis, it has only read axis, but there is a read and write axis to the conditional flags. There is a flag field in the CPSR. For that, in non-privileged mode also, there is a read-write axis, but for a control field of a CPSR, in the privileged mode, it has only read axis. In a non-privileged mode, control bits can be read. In non-privileged mode, control bits can be read, but we cannot be write. That means that we cannot be changed. So this is about processor modes. Processor modes, there are 7 processor modes. As you know, we can classify it into 2 categories. One is privileged mode and another one is non-privileged mode. Out of 7 processor modes, we have only one non-privileged mode, that is user mode. User mode is a non-privileged mode. That means what? It has only read access of a control field of a CPSR. It has only read access to the control field of a CPSR, that is user mode. We have 6 different privileged modes. One is abort mode, fast interrupt request mode, that is FIQ mode, interrupt request mode, IRQ mode, SVC, that is supervisor mode, system mode and undefined mode. These 6 are privileged mode. There is only one non-privileged mode, that is user mode. This is a table of modes and respective mode bits. Do you remember there is a mode bits in the control field of a CPSR, 5 mode bits. In this, each mode assigned by some respective mode values, 5-digit mode binary values. That means if you enter this in the mode bits, that particular mode will be selected. For example, the mode bits are 10001, then a processor operates in the fast interrupt request mode. If it is 10011, the processor operates in the supervisory mode. This is the abbreviation to represent the registers in the particular modes. So this is about processor modes. Okay, now we will study one by one. In that, first abort mode and the second one is supervisor mode. What exactly abort mode? When there is a failed attempt of accessing the memory. That means if processor fails to access memory, at that time processor enters to abort mode. So this can happen for different reasons. For example, in case processor fail to access data, otherwise it may fail to access instruction. So at that time processor enters into the abort mode. So when processor mode enters into the abort mode, when there is a failure attempt to access memory, that means that data or instruction, that time processor enters into abort mode. The second one is supervisor mode. This is another important mode, processor mode. This mode is a mode after reset state. For example, processor get reset. After that reset state, processor should enter to supervisory mode. Supervisor mode. Generally, the mode in which as this is a basic operating system kernel, so it will execute in this particular supervisor mode. It is the mode in which OS operating system kernel is supposed to operate when processor is reset. When processor got reset, after that reset state, OS kernel should be operate. So that task is performed in the supervisor mode. So this is about abort mode and supervisor mode. Next, modes are FIQ and IRQ modes. What is FIQ? Fast interrupt request. IRQ means it is a normal interrupt request. So there is a concept called interrupts. What are interrupts? Interrupts means there are some events that interrupting the normal operation. There are some events, those are interrupting the normal execution. Those are called interrupts. When those interrupts occurs during the normal operation, at that time processor mode enters in these modes, whether it may be a FIQ mode or IRQ mode. The difference is FIQ mode having high priority than IRQ mode. Both these modes corresponds to two levels of interrupts. There are two levels. One is FIQ and IRQ interrupts. FIQ, fast interrupt request, generated externally. It is generated externally. How? By taking n FIQ bit input is low. By taking this n FIQ low, it will generate FIQ interrupts. It is also disabled by setting F flag in CPSR. Do you remember there is a F flag in the control field of a CPSR? By setting F is equal to 1, by setting F is equal to 1 in the control field, we can disable FIQ interrupts. Similarly, IRQ, normal interrupt request, can be disabled by setting I bit in the CPSR. Again, in the control field of a CPSR, there is a I bit. If you set to I is equal to 1, it can be disabled. That IRQ can be disabled. So this is about FIQ mode and IRQ mode. Other modes are system mode, undefined mode, and user mode. System mode is a special version of user mode. It is very similar to user mode, but this allows full read-write access of a CPSR. In user mode, it has only read access, but in the case of system mode, it is similar to user mode, but there is extra option, that is write option. So this system mode allows read-write access of a CPSR. Then user mode. User mode is a mode intended for running user application, that is programmer application, that is called user mode. Undefined mode is nothing but when undefined instruction encounters. When undefined instruction encounters, at that time ARM processor enters into the undefined mode. So these are system mode, user mode, and undefined mode. Then there is an option in the ARM controller, we can change the processor modes. See in the diagram, look at the diagram, is a bit structure of CPSR. In that there is a control field 0 to 7 8-bit control field. In that 0 to 4 are mode bits. By writing this, by changing these bits, we can change the processor modes. So these are different bits, as you know, I bit, F bit, T bit is a state bit, it is a IRQ bit, it is a FIQ bit. Every processor mode except user mode can change. That means that we can change privileged modes. Except user mode can change the mode by writing directly to the mode bits of the CPSR. By changing these mode bits, we can change into different modes, but user mode is not possible. There are two ways to change the mode. What are those? The first one is the processor mode can be changed by a program. By using a program, we can change the mode that directly writes to a CPSR. Program directly writes to a CPSR. When it directly writes to a CPSR, mode bits of a CPSR, processor modes automatically change. For example, program writes 10111, mode changes to abort mode, like in all the different modes. So the another way of changing the processor mode is by hardware. By using a hardware, we can change the processor modes. By hardware, when the core responds to an exception or interrupts. When core responds to an hardware and interrupts, at that time by using the hardware we can change the processor modes. These are the following exception and interrupts, they can cause processor mode change. What are those? There is a reset exception, reset, then interrupt request, IRQ request, FIQ request, fast interrupt request, SWI, that means that software interrupt request, then data abort, that means that failure to access the data, that is the data abort, prefetch abort, that is failure to access the program, that is prefetch abort, and finally undefined instruction. These are all exceptions and interrupts. These can change the processor modes. So this is about mode change in the ARM processor. Okay, now we'll talk about what are exception and what is the priority of those exception. Exception means what? Exception or interrupt or suspend the normal execution. These are interrupts. These are the events. These events suspend or halt the normal execution of a sequential instruction. When these interrupts occurs, it will jump to specific location. That means that it will jump to specific mode. For example, if IRQ interrupts occurs, it will jump to IRQ mode. If FIQ interrupt occurs, it will jump to that particular mode, that is FIQ fast interrupt mode. These modes having their own priority. Why priority is required? For example, at a time if two exception or interrupt occurs, processor able to handle only one interrupt at a time. At that time, this priority will help to handle those situations. There are different exceptions, namely reset exception, data abort, fast interrupt request, prefetch abort, SWI, undefined instruction. In that, highest priority goes to reset, then data abort, then FIQ, like this. Okay, for example, in the particular time, data abort and FIQ, both the interrupt requests are happen. At that time, processor modes prefer data abort. First, it handles data abort exception because it has high priority than FIQ. Similarly, if at a time FIQ and IRQ occurs, processor handles FIQ interrupts because IRQ having less priority than FIQ. That's why processor handle first FIQ interrupt, that is fast interrupt request. So this is about different exceptions and priorities. What exception will do? It suspend or halt the normal execution, and these are the priority. When these exception occurs, that will change the mode. At that time, processor should take some necessary action. Now we'll see what are the necessary action that will taken by the processor when exception occurs. Let us take one situation. Processor mode executes in the user mode. It executing normal operation. At that time, suddenly there is a IRQ interrupt occurs. At that time, processor should change the mode from user mode to IRQ mode. From user mode to IRQ mode. At that time, processor should take necessary action because it has to return back to user mode after handling this IRQ event. Okay, what are the necessary action? The first action is it should save the CPSR status to SPSR of exception mode. Current program status register should be saved to SPSR of the execution mode. That means what? 5 exception handling processor modes are present, that is IRQ mode, abort mode, undefined mode, SVC mode and FIQ mode. Each are having their own SPSR, that is saved program status register, that is indicated by, for example, if it is IRQ SPSR, that is indicated by SPSR underscore IRQ. If it is FIQ SPSR, then how it will indicate? SPSR underscore FIQ, short abbreviation of that particular mode. The CPSR, the present status of the CPSR, that should be saved to SPSR of that particular mode. In this case, it will save to CPSR of the user mode, save into SPSR of IRQ mode. After that, it saves a program counter value. Program counter, what program counter do? It will save the address of the next instruction to be executed. But in this case, it will go to some other mode. That's why that next instruction of a user mode, that address should be stored into link register of that execution mode. Similarly, in all exception handling modes, they are having their link register of that particular mode. In that R14 underscore IRQ, program counter value stores into this link register. After that, it sets the CPSR to exception mode. When these two steps are taken, then it takes the new CPSR status of the exception mode and sets PC to the address of a exception handler. After that, it handles the exception. That means that it handles the interrupts. When it completes the interrupt, it has to come back to user mode. At that time, these operations get reversed back. That means that the user mode program counter value stored in this link register, right? This link register value again move back to R15, that is program counter. Then SPSR of this interrupt mode again move back to CPSR of user mode. When it moves to particular program counter and CPSR, processor continues its normal execution in the CPSR mode. Okay, as you know, there are three different modes, three different ARM states. One is ARM state, thumb state, and Jazz state. In this slide, we are going to see what are the comparison between thumb and ARM state. So based on these parameter, we can differentiate, we can compare ARM and thumb state. See here, when control field of a CPSR, in that there is a T bit, right? When T is equal to 0, that indicates ARM state. When T is equal to 1, that indicates processor operating in the thumb state. When instruction size is matter, instruction size, if you look at the instruction size, in ARM state it has 32 bit, in thumb state there is a 16 bit. In core instructions, ARM state having more core instruction, that is 58 core instruction it has, but in the thumb state 30 core instruction it has. In the ARM state, most of the instructions are conditionally executed. What conditionally executed? Each instruction can execute based on certain condition. But in the case of thumb state, only branch instructions having conditional execution. This is the one of the important feature, that is conditional execution, one of the important feature in a ARM processor. Data processing instruction. These instructions access to the barrel shifter and ALU. But in the case of thumb, separate barrel shifter and ALU instructions are present. Program status register. So read write in the privileged mode. It has access, read write access in the privileged mode, but in the case of thumb mode, there is no direct access to the control field of a CPSR. Register used in the ARM states are 15 general purpose register, that is R02, R14, and one more program counter, that is R15. In the case of thumb, 8 general purpose register, 7 high register along with the program counter. This is comparison of ARM and thumb state. Okay, there is one example of CPSR. You people have to interpret processor operates in which mode and which state. How you will going to interpret, in which field it will help. So this field, that is control field of a CPSR, will help to interpret the mode and state. In the control field, 0 to 4 as a mode bits. So you know mode bits of a particular modes, each mode having their own bits. So 10011 is a mode bits for supervisor mode. That's why this state, in this case, processor mode operates in supervisor mode. Similarly, there is a T bit that is equal to 0, that indicates the states. When T is equal to 0, that indicates operates in ARM state. If T is equal to 1, that means that thumb state. Okay. Then 6 and 7 bits, what? I and F bit. This is a normal interrupt request and FIQ, fast interrupt request. This is 0, that is enables IRQ. F is equal to 1, that means it disables the FIQ request. Similarly, there is a Jajal state. When j is equal to 0, that means that it depends on this bit, whether arm state or thumb state. When this j is equal to 1, this processor operates in the jazzer state. The another important field is flag field. There are 5 different flags are present: negative flag, zero flag, carry flag, V flag, and Q flag. Out of these 5, in this case, carry flag is equal to 1. That's why this is represented in capital C letter. What it means? It is the result generated. The generated result causes unsigned carry. The generated result causes unsigned carry. So finally, in this case, processor operates in the supervisor mode. The processor operates in the ARM state and is generating a carry. Okay, what we have covered in this class? What are the different processor modes available in ARM and what are the different processor states? How we can change the processor mode by directly writing the CPSR mode bits, we can change the processor modes. Then what are exceptions and their priorities? There are different exceptions having their own priority. Then when exception occurs, what are the action taken by the processor modes? We have studied that one. Then processor states and their comparison. So these are all the topics we have covered in this class. Okay, there are some descriptive possible questions. First one, define processor mode, list all different processor modes. So for this question, it may ask for 5 marks. First you have to define what exactly processor mode, then there are 7 different processor modes, right? You have to list all processor modes. Likewise, they can ask list any 5 difference between ARM and thumb state. You saw that table, so you should list minimum at least 5 difference between ARM and thumb state. It's also for 5 marks. Explain different processor modes. In this case, along with one simple diagram, you need to explain individual modes. Detailed explanation is required for this question. Then list the sequence of action taken by the processor when exception occurs. There are some steps, right? When an exception or interrupt occurs, the processor should take some necessary action, that a CPSR saved into SPSR, then PC saved to link register, then CPSR sets to exception handling address, then PC sets to address of the exception instruction. So that is the answer for this question. List the different exception, their priorities in the ARM core processor. So you know the different exception, and also you have to mention their priorities to execute, to handle for a ARM processor. So these are all the possible descriptive questions. Okay, now we'll see some multiple choice question. Number one, first one is, which type of privileged processor mode is entered due to rising of high priority of an interrupt? Understand? There are 6 privileged processor modes are present, right? So what is the answer? Options are user mode, fast interrupt request mode, IRQ mode, and supervisory mode. Okay, can you give answer? See, in the question there is interrupt. We have 2 interrupt modes. One is fast interrupt request mode and another one is normal interrupt request mode. They are telling high priority. So that means that the answer of this question is what? That is fast interrupt request mode. Okay, next question. Abort mode generally enters when dash. So when abort mode enters, so there are 4 options. An attempt access memory fails, low priority interrupt is raised, ARM processor is on reset, undefined instructions are to be handled. Okay, what is the answer? When abort mode comes into the picture, when processor failed to access data or instruction, that means that it failed to access a memory. So answer is first one. Yeah. What is the mode in this case? Low priority interrupt is raised. This is IRQ mode. This is the processor is on reset. Which one? After reset state, there is a supervisor mode. Undefined instruction to be entered, that is undefined mode. Then, when this is related to control bits, the CPSR, when J and T bits are equal to 0, the processor is in which state? ARM, thumb, Zazzle, none of the above. See, J is equal to 0 and T is equal to 0. That means what? It operates in the ARM state. So answer is ARM. Similarly, when J is equal to 0 and T is equal to 1, the processor operates in which state? J is equal to 0, T is equal to 1. T is equal to 1 is nothing but it operates in the thumb state. So answer is thumb. If J is equal to 1, then it operates in the Jazelle state. Okay, these are the reference I referred to prepare this session. Finally, I would like to thank to all content developer of ARM controller subject and moderator and subject experts. Thank you. Thank you for watching.